All right. So the fundamental theorem of calculus is actually a two-part thing. The first part talks about when you have an integral where one of your limits has a variable in it. So whether the upper or lower limit, a is a constant, x is a variable. What we see, we know that an integral means the antiderivative, right? But we have only done either an indefinite integral where I didn't give you any limits, or a definite integral where we had two numbers. We've never had the case where we had a variable in our limit. So we know that in terms of a graph, an integral gives us the area under the curve. So what's happening is if I say I'm integrating from a constant up to a variable, we're basically coming up with a formula for how to find this area. So that then I have this formula and then I could just plug in whatever value of x I wanted and quickly get the area under the curve from there. So that's what's happening if one of those limits is a variable instead of just two numbers. So we're going to start out by just kind of reasoning through this using a graph just so we kind of understand what it means. So if my function is the integral from 0 to x of f of t dt, I want to find these things. First one, g of 0. So that's saying we are going to find the integral from 0 to 0. So if you start at 0 and end at 0, what's the area under your curve? 0. We didn't go anywhere. G of 1. That means I started at 0 and I ended at 1. So if I had to estimate this area right here, what would that be, you think? Area, each box is 1, right? We took this little piece, flipped down, it's just about 1 full box. So G of 2, what we're doing is we're adding in this part. So we knew we already had 1. How many more boxes did I add? 2, so we're up to 3 total. If I said G of 3, so now we're adding in this part. So we were at 3, how much more did we add? Yeah, so what, like 4.3, you think? 4.3, 4.5, somewhere around there. If I said G of 4, when it's below the axis, what does that do? Negative. So this looks about the same as that, right? So that would take me back to 3, because those two would really just cancel each other out, the positive and negative. And G of 5, so this is also negative. Looks like it's about the same. So we've been estimating these to be about 1.3. So if I subtract off another 1.3, it'd be 1.7. Okay, so that's just using a graph to kind of illustrate what this is saying. Okay, so that integral is just your area under the curve. We know above the axis is positive, below the axis is negative, and we can use that to help simplify things. Questions here? The second part of this, I asked you to sketch a graph of G. Well, what these are really just points on the graph, because G was the antiderivative of this graph. So these are really points. So I gave you a grid here so we could plot these points. We had 0, 0, 1, 1, 2, 3, 3, 4.3, 4 was back down to 3, and 5 was a 1.7. So then we just kind of make a curve connecting these. Obviously, if we wanted to be more accurate, we would need more points, but we could use those to graph the antiderivative. Questions on that? Alright, so fundamental theorem of calculus just tells us if f is continuous, then g, the antiderivative of that, would be continuous. And if g is the antiderivative, if we take the derivative of g, we should get x. So this really isn't telling us anything too crazy, but here's the cool thing. You notice I have this as f of t right here. And this is telling me if I do g prime, so if I did the derivative of this, the derivative would really just cancel the integral and make our variable an x. So here I'm going to illustrate what this is. I'm going to do it two ways. First, I'm going to work this all out. Then I'm going to show you how we can use the fundamental theorem of calculus to shorten that work. So if I ask you to find the derivative of the integral, so if I wanted to work it out, first we would have to find the antiderivative, right? So what is the antiderivative of t squared? What is the antiderivative of 2t? T squared. And what's the antiderivative of 1? T. Okay, we need to evaluate that from 3 to x. So when you plug in your x, you get 1/3 x cubed plus x squared plus x. Minus when you plug in the 3. 3 to the third is 27 times 1/3 is 9. 3 squared is 9 plus 3. So this turns into 21. That's the integral. So then if we did the derivative, what is the derivative of 1/3 x cubed? Plus, what is the derivative of x squared? Plus the derivative of x. And what's the derivative of 2? 0. So if I work this out, we have to do the antiderivative and then we do the derivative of that. All right. From the fundamental theorem of calculus, what it's saying is if you have to do both a derivative and an antiderivative, those things should cancel each other out. One of these things was a constant, which when we do the antiderivative, we plug in and we get a number, but when you do the derivative of that number, it goes to 0. So the fundamental theorem of calculus says if it's set up like this, from a number to a variable, all you really have to do is just plug your variable into this equation. So if I replace all my t's with x's, we get x squared plus 2x plus 1, which is the same thing. So that is the fundamental theorem of calculus. Basically saying you don't have to work it out because a derivative and antiderivative are the opposite of one another. So we could just change our t's to x's and save ourselves some time. questions there? So, if I asked you to find the derivative of this, you should be able to find that derivative without doing any work. What would the answer be? Square root of 1 plus x squared. All you do, since it went from a constant up to x, it doesn't matter what that constant is, all you have to do is replace your t with an x and we're done. Are you okay with that? So I want you guys to try this one by working it out, because this is an x to the fourth, so that's a little bit different. So I want you to first do the antiderivative, then do the derivative. I'll give you a second to try that. So the antiderivative of this would be t squared minus 30t. And we're integrating from 1 to x to the 4th. So if you plug in an x to the 4th, x to the 4th squared would be x to the 8th minus 3x to the 4th. Minus, if you plug in a 1, you get 1 minus 3. So we get x to the 4th, or sorry, x to the 8th minus 3x to the 4th minus negative 2, so plus 2. Then the derivative of that would be what? 8x to the 7th minus 12x cubed. All right, so we're trying to see if we can find a shortcut. Okay, the fundamental theorem of calculus. We know that if this just went to an x, you would just plug it in. So what if we just put in that x to the 4th, we would have 2x to the 4th minus 3. What else do you need to get this? I would have to take this times 2 times what gives you 8? 4. X to the 4th times what would give you x to the 7th? Where does 4x to the 3rd come from? It's the derivative of x to the 4th. So, if it doesn't just go to a plain x, we can still do the fundamental theorem of calculus, but it's like a chain rule. You have to plug in that upper limit and then multiply by the derivative of that thing. So we can extend this a little bit. So we will try this shortcut on a problem. If I asked you to find the d over dx, so the derivative of the integral, so the derivative of the antiderivative, since it goes from a constant up to a variable, the fundamental theorem of calculus says we have to plug in that variable, but because it's not just a plain x, what else do I need? We have to multiply by 4x cubed. So this would just be 4x cubed times the secant of x to the 4th. So we can save ourselves some time. Second part of the fundamental theorem of calculus is just what we've already been doing. We already know that the integral is the same thing as an antiderivative. We already know that we can just do that and plug in and subtract. So we've already been doing that. We just didn't have the name for it, that it was the fundamental theorem of calculus. So that is kind of the summary, the two parts of that theorem. So let's just keep practicing. So some of these are like the new stuff, and a lot of these are like the old thing. So if I ask you to evaluate this integral, what is the antiderivative of e to the x? Still e to the x. Evaluate that from 1 to 3, so remember you plug in the upper minus the lower. So you get e to the third minus e, or e to the third minus e to the first. If I ask for the area under the parabola, y equals x squared, from 0 to 1. Area under a curve, what does that mean? Area under a curve is just the integral, isn't it? So all I'm asking for is the integral from 0 to 1 of x squared dx. So what is the antiderivative of x squared? X cubed. So if we plug in 1 cubed minus 0 cubed, you get 1/3 times 1, or 1/3. What do I need to do here? You could write it as like an x to the negative 1. Or if you didn't even do that, at the very least, just recognize dx over x is like 1 over x times dx. So either way there, just to kind of realize what we're looking at. So what has a derivative of 1 over x? The natural log. Which is just the natural log of x evaluated from 3 to 6. So it's the natural log of 6 minus the natural log of 3. Hey, fun question. Does anybody remember what that simplifies to? If you're subtracting logs, how do you convince them? Divide. Natural log of 6 over 3 is the natural log of 2. Good. Fun fact for today. That was the last month of problem. Huh? Yeah, the first one goes on top. The thing you're subtracting goes on the bottom. Let's look at this one. We need a good challenging problem for the day. All of these have been too short. We need something that'll make us work for it. So when we did these absolute value problems, what did I have you do? We had to separate it. To figure out where to separate it, you had to figure out what made the inside equal 0. So if I factored that, I could take out an x. How do you break down x squared minus 1? Plus 1, x minus 1. You guys should be thankful for Josiah today. I don't need so many questions. We'll be sitting here staring at each other. So we get 0, negative 1, and 1. So we're going to have multiple pieces here. Negative 1 was the first starting point, so we'll have to stop that one at 0. Then we'll have to go from 0 to 1. And then we're going to have to go from 1 to 2. So we have to break up our integral every time that absolute value equals 0. All right, between 0 and negative 1 is the same positive or negative. So think about like if you put in a negative 1/2. You would get a negative 1/8 minus negative 1/2. So negative 1/8 plus 1/2. So is that positive or negative? Positive. So the absolute value doesn't change it. Okay, between 0 and 1, if I put in a 1/2, I would get 1/8 minus 1/2, which is negative. So the absolute value does the opposite. Can I just distribute the negative through there? Negative x cubed plus x. from 1 to 2, if I plug in a 2, I get 8 minus 2, which is positive, so the absolute value doesn't change anything. Okay, so if we start simplifying the first one, antiderivative of x cubed minus antiderivative of x, x squared. You can go from -1 to 0 for that one. Okay, this one will be the same, just a -1/4 x to the 4th plus 1/2 x squared. That's from 0 to 1. Okay. So now let's evaluate each of these. So if I put in a 0, I get 0 minus, if I put in -1, get 1/4 minus 1/2 plus, okay, if we put in a 1, we get -1/4 plus 1/2 minus, if you plug in 0, you just get 0. If I put in 2, 2 to the 4th is 16 times 1/4 is 4. 2 squared is 4 times 1/2 is 2. Then the 1, we get 1/4 minus 1. Any questions right there? So we have, let's see, -1/4 minus 1/2 would be -1/4. So minus negative would be a positive 1/4. Here we get a positive 1/4. Here we get 2 minus 1/4 minus 1/2 is -1/4, so minus negative would be positive 1/4. So 2, that's like 8/4, so we get 11/4. See, no calculator needed. We can do this. I think I'm going to do one last example and then I'll stop for today. Are there questions on this one? So the last example for today says find h prime of x if h of x is the integral. So h prime means the derivative of the integral. So the derivative of the antiderivative. So what do we have to do here? Plug it in. So we're going to replace each of these t's with an x squared. But we didn't just have a plain x, so what else do we have to multiply by? The derivative of x squared, which is 2x. So x squared cubed is x to the 6th times 2x would be 2x to the 7th. There's the sine of x squared. So that was just the fundamental theorem. Bless you. Okay, tomorrow we will finish this section. We've got, yeah, I'm probably not even going to do all of these examples tomorrow. I'll probably do like 4-ish. And so you will have a good chunk of class time tomorrow to work on homework. I'm going to go ahead and give it to you so you have 10 minutes or so to start right now. You'll have more class time tomorrow, and then this will